Hi, everyone. My name is Alan. I'm the CEO of SSV Labs, which is the core team behind Compose. Compose aims to create this interop layer for Ethereum with synchronous composability, instant and atomic transactions between rollups, which has the goal to unify the various rollups and, in general, the greater Ethereum ecosystem to feel like it's one big ecosystem. We've been working on SSV Network for the past 4 years. It's the second largest staking protocol on Ethereum with roughly 5 million ETH staked. And actually, Compose is building on top of the SSV validators. The idea there, we want to create this incredibly neutral and decentralized way of doing interop between rollups in a way that can encompass a lot of different rollups. It actually all starts with the original plan to scale Ethereum. The original plan was to have shards, basically different shards on Ethereum, split the Ethereum state into different shards, and between those shards have the ability to interact and have composability between them. That turned out to be quite difficult to achieve. And so a few years ago, Vitalik and the EF team kind of pivoted towards a roll-up centric roadmap where each roll-up has similar characteristics to a shard, but doesn't have any built-in interop between them, meaning that roll-ups can't really talk with one another unless we do something on top of. And that created a lot of fragmentation. Each roll-up has its own user base, its own liquidity, its own dApps, and they don't really interact with one another. And that creates a situation where Ethereum itself doesn't feel like one big chain anymore. It feels like a lot of different economic islands, which are loosely coupled or loosely connected to one another. And I think that's really a big challenge for Ethereum, especially if we consider other blockchains that really suffer from that. Things like Cosmos, for example. If we don't fix this, it can be a really challenging period for Ethereum. There are a few different patches and bridges that we've built on top of that try to create this interop or composability between rollups. But those are not really sufficient. They don't really achieve the goal of making Ethereum to feel like just one big chain. One of those solutions is asynchronous message passing. The idea is that we can move messages through some kind of a committee or a trusted party, and those messages can reach another chain, and then you can do something with those messages. Think about it as an asynchronous way to call contracts from one chain to the other. The problem is that the latency between those calls, and because each call is asynchronous, meaning that you send it, but you don't really know when it lands on the other side, means that you can't really build multi-chain interactions in an easy and frictionless way. Another point or another type of interop is intents. Intents can kind of flip the script around and say, what exactly does the user want to do? And then I'll offsets off-chain intermediaries to fulfill that desire. So for example, if a user wants to move assets between one chain to the other, they describe what asset they want to move and how much fees are they willing to pay for it. And some off-chain intermediary will fill or not fill that request. The problem is that, one, it depends on intermediaries, and also it depends on a lot of liquidity. So it's limited to the types of use cases it can actually fill. That's why most of it is swaps and bridges, because the more complicated use cases are actually require equally complicated intermediaries. And also because it's liquidity focused, it requires a lot of liquidity, and so it's concentrated around very few assets. What we're trying to build is a synchronous composable interop layer, meaning that transactions feel like Ethereum. We're used to have those type of transactions on Ethereum, transactions which offer one, composability, meaning that you can have multiple interactions in a single transaction. Atomicity, meaning that each of those interactions either happen together or not at all. And synchronicity, meaning that they happen in one transaction, one after the other. Those three properties are exactly what Ethereum transactions feel like. And when we bring them to the cross-chain world, then it's named synchronous composability. The idea that we can have instant and atomic transactions between rollups are so fundamental, they change completely how interop and composability between rollups look and feels. If we need to kind of compare all of those different solutions, we either have slow but very generic solutions like asynchronous message passing, or we have very fast, but also very specific solutions, which are intense, meaning that they can't really do everything. With Compose, what we're trying to do is actually have a very fast, but also very expressive and generic type of interop between rollups. More specifically, we try to consolidate liquidity dApps and users, create a cross-chain feeling or cross-rollup transaction feeling like Ethereum itself, and having it in an instant, meaning that whenever it hits the block, the execution happens, and also ZK guarantees for atomicity. This idea is really kind of changing the way we can look and feel between rollups. And it's all based on this idea called shared publishing. Shared publishing is the idea that different rollups can have different sequencers, independent sequencers, but they all come together through some kind of a coordination layer or a publishing layer, which aggregates ZK proofs and puts them on the L1, and in that way can enable atomicity and cross-chain transactions. The shared publisher is actually based. It's run by Ethereum validators, and to make it credibly neutral and extremely decentralized, so any rollup can integrate. You'll also notice that it's not just about opted-in rollups. It's also about external rollups like Base and Arbitrum that we found a way to actually connect and make synchronous composable transactions between them and compose rollups. And that's really powerful. That means we can tap into the liquidity, user, and dApps of those rollups. So imagine that all of those rollups and others are just frictionless. You can interact with any dApp and any user in an instant. This starts with a very simple concept called the mailbox. The mailbox is just a contract that we deploy on each rollup, and it holds the messages coming in and out to that rollup. The mailbox itself is extremely simple, and it's also an important building block to verify execution is equal and valid on both rollups. So the inbox on one rollup needs to be equal to the outbox of another rollup. That's how we just check that execution is valid. And it happens through a simulation phase. Every transaction that is cross-chain post-rollup goes through a simulation that the sequencers are doing. And during that simulation, they pre-populate messages into the inboxes of the various rollups. Then they execute and produce blocks independently. Each sequencer and every rollup has its own sequencer, and it's completely independent. They build the blocks and ZK proofs for those blocks and publish them through the shared publisher. The shared publisher basically takes those blocks, aggregates them into one single ZK proof, and puts them on Ethereum for settlement. That means that we can also lower the cost of proving each individual rollup. Now, the powerful thing about it is that synchronous composability opens the door for many more use cases than the current interop world offers us. So if we even take bridging and swapping, for example, we don't need intermediaries with synchronous composability because we literally can just interact with DEXs and directly on another rollup. And so without intermediaries, that means that we lower the cost. Any token can participate, any rollup can participate, and that's really powerful. But it also expands far beyond that. So, for example, cross-chain flash loans all of a sudden are a possibility, and multiple rollups in one transaction, 3, 4, 5 different rollups in one transaction. We can do atomic arbitrage trading. We can just enable developers to do arbitrary read and write to any contract on any chain. That's a very foundational thing for developers. We can even do NFT bridging, which is something which is not really available today. All of that leads us to a very different landscape of Ethereum, a landscape where dApps can deploy on one rollup and be reachable from any other rollup connected to the network. Liquidity can flow freely between rollups. Users can be on one rollup but interact with another. And more importantly, Ethereum just feels like just one big chain instead of those economic islands spread around with loosely coupling between them. And so this is kind of what Compose is trying to do, this vision of just connecting the entirety of Ethereum. We've been developing it for the last few months, and right about now we're hoping to release the first public testnet for Compose. And also a web demo that showcases a bunch of those use cases I saw. So you'll be able to do bridging, swapping, flash loan, stuff like that through a web demo showing you what synchronous composabilities can do. By the end of year, we'll integrate Base for the first kind of major external rollup into Compose. You'll be able to interact with the base testnet rollup synchronously, just without any friction. As a developer, this is huge. And ultimately, throughout 2026, we're hoping to reach mainnet. And so if you want to learn more and kind of join us, we're actually hosting a really cool event today around 7 p.m. If you want to learn more about synchronous composability or interop in general, we'll be happy to have you. Thank you so much.